being driven off of the carbohydrazide. At this point, they increase the drum blowdown, and you see a significant decrease in the cation and a slight decrease in the degassed cation because the degassing unit is removing most of the CO2. And then at this point, they begin feeding ammonia, and you see the impact on the cation conductivity and degassed conductivity. This is a little bit busy, but what you're looking at here is startup of a combined cycle unit. It's a cold startup, and we're going to be comparing the cation versus the degassed cation conductivity. And the lines in the graph that are important is this line. This is the megawatt load. This green line, which is the cation conductivity. And this blue line here, which is the degassed cation conductivity. And this red line here is the 0.5 microsiemen limit in action level 2 for Siemens, at which point when the degassed cation conductivity is below that, you can admit steam to steam turbine, assuming the other chemistry parameters are also within action level 2 and trending downward. So you see there is a significant difference in the degassed cation conductivity versus the cation. And here's where they synchronize the gas turbine to the grid, and you can see the degassed cation conductivity went well below the 0.5 limit, then slight increase above it, then quickly drop down to 0.5 and less. Whereas the cation conductivity was as high as 2 microsiemens, and after a couple of hours or longer, the cation conductivity was still above 1 microsiemen. And you may wonder why the degassed conductivity increased to the value of the cation conductivity here. Well, just to show that the degassed conductivity was working properly and measuring accurately, the reboiler was powered off. Therefore, it's no longer degassing. As you can see, then the conductivity matched the regular cation conductivity because it's no longer degassing. So what is the practical impact of degassed conductivity on your operation? Well, here's 4 different case studies, 3 of which were cold starts and 1 was a warm start. In this first column here, it's the time from synchronization of the gas turbine start to when the cation conductivity was less than 0.5 microsiemens. The center column is time from gas turbine start to the time in which the degassed cation conductivity was less than 0.5 microsiemens, which, as you can see, was significantly less. And the third column is the time differential between the time at which the cation versus the degassed cation conductivity was less than 0.5 microsiemens. And as you can see in case 1 on the cold start, degassed conductivity less than 0.5, almost 4 hours sooner than the traditional cation. Cold start 2 is almost 2 hours. Cold start 3, it was almost 4.5 hours. And then even on the warm start, it was almost 2 hours sooner to reach less than 0.5 than the traditional cation conductivity. So, utilization of degassed cation conductivity can reduce startup times as much as 62 to 70%. So, in summary, degassed cation conductivity is a valuable tool for troubleshooting. Degassed conductivity can reduce your startup time significantly. And not all degas systems are the same accuracy, and that's dependent upon the design.
All right, well, thank you, Randy. And as I say, we'll be sending a thank you email to you and a request for a survey rating today's webinar. And we hope to see you on our next webinar. Well, thank you for attending and have a really great day. Bye-bye.